Hello friends. So this is your first time in the Special Technology 1 class. So plastic and polymer technology, we will be beginning our unit number 3, that is natural polymers, which includes cellulose and its derivatives. So as I told you, the best book that you can refer for this is none other than Gowarikkar's book, Polymer Science by V.R. Gowarikar. It's a wonderful book. He has explained everything nicely over there. So let us begin. So, what do you know about natural polymers? What are polymers basically? Polymers are basically nothing but macromolecules. Means they are having more than one molecule, or they are having a chain of molecules linked one another, and then they form a big molecule, and that macromolecule is called as polymer. And monomer is a single unit of that macromolecule. So natural polymers, one of the most common example of natural polymers is cellulose. Cellulose is a very structure with stacked chains that result in stability and strength. So common examples of cellulose are, what are the common examples of cellulose? Any idea? Think. It's very important to think. Don't just listen to me, also think. Cellulose. See, it is found in plant cell walls. And it has a lot of use. It is used in making paper. It is used in making clothes. And it is also a source of fiber in the human diet. But we cannot digest cellulose. Okay. So cellulose is very structured with stacked chains that result in stability and strength. The strength and stability comes from the straighter shape of cellulose caused by glucose monomers joined together by glycogen bonds. The straight shape allows the molecules to pack closely. So basically he's talking about the structure of cellulose, which we will understand better once we see the actual structure of cellulose. Cellulose is very common in applications due to its abundant supply, its biocompatibility, its environmentally friendly nature. Cellulose is used vastly in the form of nanofibrils called nanocellulose. Nanocellulose at presents if presented at low concentration, produces a transparent gel material. This material can be used for making biodegradable, homogeneous, dense films that are very useful in biomedical field. So this is one of the use of cellulose. Cellulose has many derivatives also, which are used for other purposes, which you will see as we go ahead in this chapter. This is unit number 3 of Special Technology 1, Plastic and Polymer Technology Department, LIT College. I welcome you all once again. So, till now what we have seen is just a basic idea what natural polymers are. Okay. So now let us see the exact structure of cellulose. So see, this is the exact structure of cellulose. So you can see here there are cellulose is a naturally occurring linear stereoregular polysaccharide made up of beta D plus glucose residues. Its structure can be written as follows. So firstly I will like to tell you it is a naturally occurring thing. Second, that's why it is called as a natural polymer. Secondly, it is linear. As you can see, the structure, it is linear. And then stereoregular. What is stereoregular? Can anybody tell me? It is a something which is having a ordered arrangement. Okay, ordered arrangement of molecules, that is called its stereo regularity, and it is a polysaccharide. Now what is a polysaccharide? What is a polysaccharide? A carbohydrate whose molecules consist of number of sugar molecules bonded together, that is a polysaccharide. Okay, made up of beta D plus glucose residues. Now this beta D plus glucose residue is a new term for all of you. So I think here the D stands for dextrorotatory. You must have heard about dextrorotatory and levorotatory, but you don't know the exact meaning. So let us find the exact meaning of it. The exact meaning of it is this thing, this difference. This is this is actually difference between alpha and beta. So alpha 1 is like this, the point number 1 carbon. If the OH group is on the bottom side of the point number 1 carbon, then it is alpha rotatory, and if it is at the top of the first carbon, then it is beta rotatory. So that's the difference between alpha and beta. Now let us see the difference between levorotatory and dextrorotatory. So glucose is by far the most common carbohydrate and classifies as monosaccharide, and aldose or hexose is also reducing sugar. It is known as dextrose because it comprises more of the sugar molecules, therefore it is a polysaccharide, and therefore because of its dextrorotatory, meaning that an optical isomer, it rotates plane polarized light to the right, and also an origin of the D designation. So if it rotates the plane polarized light in the right, it is dextrorotatory, and if it rotates the plane polarized light in the left, it is levorotatory. So this is just a brief introduction of cellulose. So whenever someone asks you what is cellulose, all you can say is cellulose is a naturally occurring linear stereoregular polysaccharide made up of beta D plus glucose residues. Its structure can be written as follows. I know the structure is complicated when you see it for the first time, but if you draw it and then you practice this and then you just try to remember it, then definitely you can, get accustomed with it. So the thing is like now let us go ahead. Cellulose is a versatile polymer which can be found in plenty in nature in the form of cotton, hemp, jute, flax, etc. So all these are like cloth making material. Also good percentage of wood consists of cellulose. Suppose if you are sitting in a classroom and your desk, it is made up of wood, so you are like touching a wood, and that wood is nothing but cellulose. Cellulose has an extremely high degree of crystallinity. Why crystallinity high? You can completely understand this because crystallinity is directly proportional to the ordered nature of the molecule, and as I said, it is a stereoregular polysaccharide, so there must be a lot of ordered and proper arrangement of the molecule, therefore high degree of crystallinity. Crystallinity means more solid structure, and this is due to the formation of several hydrogen bonds originating from its hydroxyl groups. Okay, this is also one of the reasons. Its high stereoregularity, that's another reason, is also a contributing factor for its high crystallinity. Cellulose has a very high melting point, and in fact it decomposes before beginning to melt. Wow, this is interesting thing. Cellulose has a very high melting point and it decomposes even before it begins to melt. So this is like, something which does not melt, it simply decomposes. It is generally resistant to dissolution in several solvents. So It is hardly soluble in many solvents, though it can swell in some, such as water, owing to the presence of hydrogen bonds. A closer analysis of swelling process shows that it takes place only in the oh my god, so it takes place in what? Excuse me for a second, guys, because in this PDF I think so there is one page missing. So this is really a glitch which I didn't want it to happen, but since it is the first lecture, so we will, as the time passes, we will learn how to use the system properly. A closer analysis of swelling process showed that it takes place only in the that's why I told you to buy the books, because you can't rely on the soft copies always. You need a hard copy with yourself to get a better understanding of the subject. Give me a second, guide, please bear with me, because I didn't know any such thing would have happened, but it did. So now we have to just go with it. So if you have the book, you can see owing to the presence of hydrogen bonds, because a closer analysis of swelling process shows that it takes place only in the amorphous regions, whereas the crystalline regions are practically not affected at all. Mostly cellulose is dissolved through chemical reaction. In industry, cellulose is usually dissolved and subsequently reprecipitated in a pure form. This form of cellulose is known as regenerated cellulose. So if anybody asks you what is the regenerated cellulose, you can tell them in industry, cellulose is usually dissolved and subsequently reprecipitated in the pure form. This form of cellulose is known as regenerated cellulose. We'll see this in detail as we go ahead. Cotton contains the highest percentage of cellulose, with only small amount of other substances such as protein, pectin. Cotton fabrics lawn well compared to many of the synthetic fibers, which tend to lose strength in wet condition. In fact, it is found that the strength of cotton fiber is almost 25% higher in wet condition than when it is dry. Another interesting point in favor of cotton fabric is that it can be folded and unfolded several times without loss of strength. So cotton fabrics are so foldable. In comparison to silk or wool, cotton is a better conductor of heat, and has also excellent moisture absorption capability. So people always advise you to wear cotton clothes in summer season because of this very good point of the cotton fabric, that it has very good it is a very better conductor of heat and also excellent moisture absorption capability. These two properties make it an ideal clothing material for wear in humid summer weather. Cotton fabrics can be easily dyed, hence are easily amenable for appealing and elegant design. So you can easily impart color to the cotton fabric or the clothes made of cotton. So now let us see the rayon. Rayon, a very interesting thing. So rayon, as the name suggests, it is also known as viscose. It is in fact regenerated cellulose. The thing which earlier I was talking about, that thing is called regenerated cellulose. In an actual manufacturing process, the initial step is the production of alkali cellulose. So first you produce an alkali cellulose. The reaction is very simple. Cell OH plus NaOH gives you cell ONA plus H2O. Okay. So this is like a very important reaction. I want you guys to see this reaction, so I would just show you this reaction. How can I show you this reaction? Please bear with me, guys. Okay. Yeah. So it is cell cell OH. This is how we represent cellulose plus NaOH. So plus NaOH. Just a second. Just give me a second, guys. Please bear with me. You know, in life, sometimes you have to just be patient. So meanwhile you can just, you know, relax a little bit. You know, life is amazing. There's nothing to worry about. Just study hard and you will be rewarded. Fail to do so, the consequences will be severe. So now I would like to tell you the reaction which I was actually talking about. So I know it took a long time. Sometimes you have to wait. Yeah, so here you can see the reaction. Okay. Oh my god, I didn't know it would have been so bad. Anyways, let's take another one. Please bear with me, guys. I'm sorry, you know, sometimes this happens, and in times like these we have to be patient. Finally, you can see this reaction, right? Here cell OH NaOH giving you cell ONA plus H2O Then the cello-Na, which is the alkali cellulose, further reacts with carbon disulfide CS2, giving you cell O C double bond S and single bond SNA. So this is the basic reaction, which is the starting reaction. Okay, to get alkali cellulose, and then from that alkali cellulose, when it further reacts with CS2, it gives us cellulose xanthate. Okay, now, so where were we? In actual manufacturing process, the initial step is the production of alkali cellulose. This is affected by treating cellulose obtained from wood pulp with strong alkalis at relatively low temperature. The alkali cellulose thus obtained is further treated with carbon disulfide to produce what is known as cellulose xanthate. Representing cellulose as cell OH, the reaction involved can be written as follows. So once again, these two reactions, okay. Cell OH giving plus NaOH giving cell ONA, that is alkali cellulose plus water. Then cell ONA reacting with carbon disulfide giving cell O C double bond S single bond SNA, which is cellulose xanthate. So now after this, the alkali cellulose is held in excess of carbon disulfide for 3 hours in a tub, and at the end of the process, the unreacted carbon disulfide is removed. The cellulose xanthate formed is dissolved in dilute solution of sodium hydroxide. The solution thus formed is industrially known as viscose solution. Cellulose xanthate is an unstable product and will generate pure cellulose through hydrolysis as shown. So, the process of hydrolysis. So here you can see cell O single bond C double bond S SNA, that is the cellulose xanthate, on hydrolysis giving you this product, but this is a very unstable product, and hence on hydrolysis gives you pure cellulose and carbon disulfide is removed. So the process of hydrolysis and the simultaneous regeneration of cellulose are achieved by treating the viscose solution with dilute solution of sulfuric acid containing sodium or ammonium sulfate. If viscose solution is injected in a bath of sulfuric acid and sulfate in the form of fine jets, the cellulose is generated in the form of glossy filaments. So this viscose solution is a very unstable solution. That's why it needs further hydrolysis and we get cellulose. And this is a regenerated cellulose, of course, and that is why it is called as rayon. Now let's go ahead. I hope there are no glitches in future, but let us say now. Cellophane, whoa, such a relief. Cellophane, any idea what cellophane does? Anyway, let's see the rayon once again. Rayon is nothing but an artificial textile material composed of regenerated and purified cellulose derived from plant sources. Developed in the late 19th century as a substitute for silk, rayon was the first man-made fiber. See, you people are so blessed by the gods that you are getting the knowledge of the first man-made fiber, which is rayon. So you should be proud of yourself, proud of your department, proud of your college. We are the second best in the Asia in chemical engineering, of course, and technology. So cellophane. Cellophane is a thin transparent sheet made of regenerated cellulose. Its low permeability to air, oil, greases, bacteria and water makes it useful for food packaging. Cellophane is highly permeable to water vapor, but may be coated with nitrocellulose lacquer to prevent this. As well as food packaging, cellulose is used in transparent, pressure sensitive tape, tubing and many other similar applications. Unlike many other similar materials, cellophane is biodegradable. So let us see cellulose, cellophane, one of the derivatives of cellulose, of course, and then cellophane. It is a transparent film commonly used in our day-to-day life. It is also regenerated cellulose made in the form of thin film. In the manufacturing process, the viscose solution is extruded into a thin film and then made to pass through a trough containing sulfuric acid, and ammonium sulfate and sodium sulfate. During this process, the xanthate group are eliminated and cellulose is precipitated as earlier explained. Subsequently, the film streams through another throw containing glycerol. Here, an appropriate quantity of glycerol will be absorbed by the film, which in turn serves as a good plasticizer for sulfate. Plasticizers are nothing but strength increasing materials for plastics. On drying, this thin film of cellophane is produced. Its well-known uses are in the packaging and wrapping industries. So basically, glycerol is responsible for giving more it serves as a good plasticizer for cellophane. It basically increases the elasticity of the material and makes it more flexible, bendable, and its strength also increases. So basically, strength increases not in the terms of hardness but in the term of bending and elasticity, and it does not get break easily. So now cellulose nitrate. So all the people who are fascinated by explosives will be very happy to see this product. Nitrocellulose, also known as cellulose nitrate, flash paper, flash cotton, gun cotton, and flash string, is a highly flammable compound formed by nitrating cellulose through exposure of nitric acid or a mixture of nitric acid and another acid, usually either hydrochloric or sulfuric, or another powerful nitrating agent. One of its first major uses was as gun cotton as a replacement for gunpowder as propellant in firearms. It was also used to replace gunpowder as a lower order explosive in mining and other application. So examination point of view, you will have to follow the book. Now you see this. I hope it's not a glitch. Bear with me. Gone are the days. Now it's online teaching. So we have to, change our attitudes. We have to be a little bit more patient. Now, nitrocellulose or cellulose nitrate. Oh my god. Glitches. I hate glitches, man. Just another glitch. I can't believe this is happening, guys. Please bear with me. So nitrocellulose or cellulose nitrate or gun cotton. Okay, cellulose nitrate polymer, also known as nitrocellulose, is a nitric acid ester of cellulose. So it is a nitric acid ester of cellulose. Cellulose is nitrated by a mixture of strong nitric acid, sulfuric acid, and a small quantity of water. At elevated temperature, the reaction rate increases, but so does the chain degradation. So you increase the temperature, the reaction will be faster, but chain degradation will also occur. So we want to avoid this problem of chain degradation. So to overcome this problem, nitration is done at around 20 degrees Celsius. Means the temperature is not increased, okay, that much. Usually the reaction will be completed within 45 minutes, after which the reaction mixture is transferred and centrifuged to separate out the product. Next, the product is purified by washing and is stabilized by dilute alkali and subsequently bleached. The last traces of water present are removed by washing with alcohol. Depending on degree of nitration, cellulose nitrate has different application. So first you need to understand what is happening here. It is a nitric acid ester of cellulose. So to make nitrocellulose, we have to carry out esterification reaction of cellulose. For carrying out esterification reaction of cellulose, we have to nitrate it with a mixture of strong nitric acid, sulfuric acid and a small quantity of water at elevated temperature like 20 degrees Celsius to and then usually the reaction will complete in within 45 minutes, and the reaction is then transferred and centrifuged to separate out. So what is centrifuge? Can anybody tell me? Centrifugal force, separation by centrifugal force. An apparatus that rotates at high speed by centrifugal force substances of different densities as milk and cream. So naturally you must have heard about the centrifugal force. It acts away from the center, so more density product stays near the center, low density product goes away from the center, and that's how the product is separated. So usually the reaction will be completed within 45 minutes, after which the reaction mixture is transferred and centrifuged to separate out the product. Next, the product is purified by washing and stabilized by dilute alkali. So washing is very simple and stabilized by dilute alkali and subsequently bleached. So bleaching, what is bleach? Bleaching is nothing but cleaning. The last traces of water present are removed by washing with alcohol. Depending on the degree of nitration, cellulose nitrate has different. So the degree of nitration will make different product. Okay, so this is a very important part. Different applications. For example, nitrocellulose with nitrogen content of more than 12.3% is used as explosive. So you should remember this by heart. More than 12.3% nitrogen content in nitrocellulose, it is an explosive. Gun cotton example. Whereas nitrogen contained with 10.5% to 11% in the nitrocellulose is used as cellulite plastics. Then 11 to 12 nitrolacquers. Then 12 to 12.3 photographic films. Celluloid has an excellent impact resistance and is one of the most inexpensive plastic available. It is used to make molded decorative articles, fountain pens, frames for spectacles, etc. Nitrolacquers find application in paint and surface coating industries. So nitrolacquers are basically paints. The greatest advantage of cellulose nitrate is its very high inflammability. So it is like it catches fire very easily and it explodes. And for this reason, the present day photographic films are made up of cellulose acetate instead of nitrocellulose or cellulose nitrate, because we don't want any explosions while viewing our photographs, right? So now cellulose acetate is a replacement for overcoming that problem. Now, great, we have been on for like half an hour. Now, cellulose acetate and other related polymers. Cellulose acetate is a acetate ester of cellulose. It was first prepared in 1865. Cellulose acetate is cellulose acetate is used as a film base in photography, as a component in some coatings, and as a frame material for eyeglasses. It is also used as a synthetic fiber in the manufacture of cigarette fillers and playing cards. Another important cellulosic plastic is cellulose acetate. It is produced by the action of acetic anhydride on cellulose. So acetic anhydride and cellulose, when they both react, you get cellulose acetate, which is nothing but a cellulose. What is it? It is nothing but a acetate ester of cellulose. Yeah. The catalyst used for this reaction is either sulfuric or perchloric acid. So very important it is to know cellulose. You can easily represent cellulose by CellOH. Then cellulose acetate by CH3CO twice O. Then cell O, and we know the acetate group CH3CO. So that is attached, and the byproduct is acetic acid. The product obtained by complete acetylation, where all the three hydroxyl groups in each glucoside ring of cellulose are acetylated. It is called primary cellulose acetate or cellulose triacetate. So guys, just bear with me, I'll come in 2 minutes. It's a wonderful day, hope you all are enjoying. So let's go ahead. This plastic is used for the manufacture of fibers. Partial sulfonification of primary cellulose acetate leads to the formation of secondary cellulose acetate containing 2.2 to 2.5 acetate group per glucoside ring. Sulfonification is a process that involves conversion of fat, oil or lipid into soap and alcohol by the action of heat in the presence of aqueous alkali. Soaps are salts of fatty acids, and fatty acids are monocyclic acids that have long carbon chain. So sulfonification is nothing but a process that involves conversion of fats, oil into soap. So if we do the partial sulfonification of primary cellulose acetate, it will lead to the formation of secondary cellulose acetate containing 2.2 to 2.5 acetate group per glucoside ring. It is a very important plastic and is used for the manufacture of non-flammable safety cinematographic films. As I said earlier, cinematographic films are now being made by cellulose acetate because they are not flammable. Molded articles and fibers. Cellulose acetate butyrate is another important cellulosic plastic. It is made by esterification of cellulose with a mixture of acetic anhydride and butyric anhydride. Just give me a minute. Esterification is controlled in such a way that final polymer contains 26 to 29% of acetyl, 17 to 48% of butyl groups. Cellulose acetate butyrate has several better properties such as high impact strength, good dimensional stability, excellent compatibility with plasticizer, and much lower moisture absorption as compared to cellulose acetate. This plastic is extremely used in the manufacture of automobile components. Two other cellulose based plastics are cellulose propionate and cellulose acetate propionate. Now ethyl methyl cellulose. Ethyl methyl cellulose is thickener, vegetable gum, foaming agent and emulsifier. Chemically, it is a derivative of cellulose with ethyl methyl group attached to ethyl linkages. It can be prepared by treatment of cellulose with dimethyl sulfate and ethyl chloride in the presence of an alkali. Ethyl cellulose and methyl cellulose are the ether derivatives of cellulose and are prepared from alkali cellulose by treatment with methyl chloride or ethyl chloride. So you take simple alkali cellulose, CellONa, it is represented by alkali cellulose, CellONa. Then you take methyl chloride and you will get an ether derivative of cellulose, that is CellOCH3 plus NaCl as byproduct, and in this case you will get CellOC2H5. This is the methyl group, this is the ethyl group. So ethyl cellulose is flexible and tough even at very low temperatures. It has better mechanical and electrical properties compared to other cellulosic plastic. Both methyl cellulose and ethyl cellulose find application as finishing material in textile material and paint bases, textile industry and paint bases. Now carboxyl methyl cellulose. Carboxyl methyl cellulose or cellulose gum is a cellulosic derivative of carboxyl methyl group. So this is the carboxyl methyl group bound to some of the hydroxyl groups of monomers that make up the cellulose backbone. So the monomers of the cellulose is also called as glucopyranose. It is often used as sodium salt, sodium carboxyl methyl cellulose. Okay, so now let us see. Carboxyl methyl cellulose, usually known as CMC, is produced as sodium salt by reacting cellulose with NaOH and chloroacetic acid. So first you take cellulose, that is CellOH, 2 molecules of NaOH, and what is this? Chloroacetic acid. So you get NaCl as byproduct and 2 molecules of water, and you get carboxyl methyl cellulose. Okay, carboxyl methyl cellulose you get, which is nothing but a cellulose derivative with carboxyl methyl groups, CH2COOH. So CH2COO Na, so carboxyl methyl cellulose. CMC is used as a thickening agent in textile additives, cosmetics, cakes, ice creams, and as a protective colloid in suspension and emulsion polymerization system. So this we will learn this. These are the techniques of polymerization, bulk, suspension, emulsion, which we will learn in future. So this was regarding cellulose and its derivatives. So one more topic is there for you guys, that is lignin. So lignin is a class of complex organic polymer that form key structural material in support tissues of vascular plants and some algae. Lignins are particularly important in the formation of cell walls, especially in wood and bark, because they lend rigidity and do not rot easily. Global commercial production of lignin is a consequence of paper making. So lignin is the product used in paper making. So paper technology friends of yours can tell you more about it, and it is one of your assignment for this unit number 3 of Special Technology 1, Plastic and Polymer Technology, that find more details about lignin. So hope you guys understood what I was talking about, everything, cellulose and its derivative. Feel free to ask me question on the WhatsApp group. You can also email me at mayuyankee13@gmail.com, and all the reactions you have to remember by heart. plus the percentage and how the percentage of nitrogen content in nitrocellulose gives us different products, and each and everything learn by heart, understand it very well. It's all given in the Govarikar book. I don't know which edition you have, but it is from page number 196 to 200. So 196 200 you can just learn, and your unit number 3 is sorted. So I want you guys to take this very seriously. If there's something you didn't understand, first you research on that particular thing which you didn't understand on the Google. Feel free to use the internet, and even by using the internet, if you can't get the answer, then feel free to contact me. And all the reactions you have to learn. You must have done this in your 12th standard, so this is this is the time to reuse the skills which you have learned in the 12th standard. So I welcome you all in this amazing journey of your second year plastic and polymer technology course. Fear no one and be proud of yourself, because this is a very wonderful course, and by getting this degree you can expect a very bright future. I know there was some glitches because this is the first lecture. I hope this won't happen in the further coming classes. So cellulose and its derivatives, and the structure is very important. You have to remember the structure because this carries marks. Unit number 3, and be attentive. The best part about online lectures is you can really pause and listen it again and again and again and again and again and again and again. So class, see you next time. Till then, bye bye.